Hello. For today, for chapter 10, this is for people that did not get the lesson in class. I'll be going over most of the cardiovascular system. I might be skipping around from slide to slide from time to time, but overall, we're going to be going over the cardiovascular, immune systems, and blood. This is for medical terminology, and it's just for extra help. And you may be working through this book and you might not fully understand the functions and how the heart works. I'm going to do my best to explain it. And moving on. So the cardiovascular system is most referenced to the heart and all the vessels that make up the circulatory system. Overall, mainly there's three types of vessels. There's arteries, capillaries, and veins. There are things like venules or arterioles, which are just smaller arteries or smaller veins. But overall, the cardiovascular system is arteries, capillaries, and veins, and then also the muscle that's in the center of your chest called the heart. So with the heart, it may look overwhelming at first, but just think that the heart is a circle. That's why they call it the circulatory system. Heart is a circle. It's the engine of your body. Without your heart, it'd be a very hard time living. Heart disease is the number one largest killer in the United States. It's one of the most important organs in your body. And for example, you can live without a brain, but you can't live without a heart. The heart kind of acts on its own. It can beat on its own. It can act on its own, but also it is influenced by the brain, influenced by certain hormones like stress hormones or adrenaline. But the heart is a muscle that can get stronger with exercise. It can act on its own, like I said, but it's got its own electrical current telling it to squeeze or relax. But just know with the heart, it starts on the right side. This may look like the left side for you, but this is the right side of the heart. So the right side of the heart is this area right here. So this is like if this is your heart. Okay. What we'll start with is the vessels called the vena cava. The vena cava is one of the largest veins in the body, but just know that veins, they carry blood to the heart. They carry blood to the heart. Where the blood is coming from is, with these vena cava, is from the body. Anything that's below the heart or below the chest, you're going to get blood returning from the inferior vena cava. Inferior meaning below. Anytime you're getting blood returning from the body that it's above the heart, like the brain, the neck, the face, that's coming from the superior vena cava. So with the superior vena cava, blood is coming from above the heart and it's entering, and also from the inferior, from below the heart. It is filling up first in the smaller chamber, always a smaller chamber, called the atrium, the right atrium. The right atrium is always the top half of the heart, the atriums. So in all, there is 4 chambers. So the blood's going to be filling up in the right atrium here, right here. When the blood fills up, what's going to happen is then a valve or a gateway is then going to open up. The lub-dub action, which like if you hear someone's heartbeat, the lub-dub action is actually the valves in your heart opening and closing. So the first valve that's going to open is what's called the tricuspid valve. The tricuspid valve, the reason why it's called that is because it has 3 flaps that open and close. So we have the blood in the atrium. Okay. When it opens up, the tricuspid valve, the blood's then going to flow downwards into the right ventricle. So in the right ventricle, ventricles are always larger than the atrium. The right and left ventricle is separated out by this really muscular wall called the septum. You have a septum in your nose, but the septum is the wall that separates the right and left ventricle. When the heart squeezes, what's going to happen is the blood that's in the ventricle that has come from the atrium is going to flow upwards into what's called the pulmonary artery. The reason why it's the artery, right? It's not called a vein, even though it looks blue, is because that it's carrying blood away from the heart. It's carrying blood away from the heart. So primarily, though, arteries will carry blood with oxygen in it, and veins will carry blood without oxygen in it. But this pulmonary artery is going to be carrying blood with little to no oxygen. So you're always going to have some oxygen in your bloodstream, but when the blood is coming from the body, it's already been used up, and it's primarily composed of the gas called carbon dioxide. So carbon dioxide is a byproduct of cellular respiration. So when your cells use and abuse nutrients and oxygen, what the blood is going to carry then is carbon dioxide. Carbon dioxide is not used by our body, and our body is almost toxic to our body, especially to our brain. You can make you feel lightheaded. Too much carbon dioxide, you'll pass out. But we're on this path right now where it's going to the lungs. So the lungs, we know when we breathe in oxygen. So we breathe in oxygen, and the oxygen goes down into our lungs, and it's located in our bronchial tubes, in our alveoli, which are the air sacs at the ends of the bronchial tubes. But when the bronchial tubes have oxygen, what's going to happen is the alveoli will take out carbon dioxide and replace it with the oxygen that you're breathing in. So your blood is going to your lungs, collecting oxygen, and then coming back. Where it's coming back is what's called the pulmonary veins. Again, veins carry blood to the heart. The blood is then going to enter in the left atrium with oxygen in it. Okay, so it fills up here with oxygen, oxygenated blood. So the blood with hemoglobin is binding with the oxygen molecule and is filling up in the right atrium or the left atrium. Then, again, just like what valves do, valves all the time, they open and close, the lub-dub action. It's going to head downwards to the mitral valve, or otherwise known as bicuspid. The bicuspid valve, again, is that gateway of letting blood in and preventing blood from going backwards or flowing backwards. Blood fills up here in the left ventricle. The left ventricle is larger. And then what's going to happen is the heart will squeeze and shoot the blood up through the aortic valve. Again, valves, always valves. Blood with oxygen is going up through the valve, the aortic valve, and then out the largest artery in the body called the aorta. The aorta is like the mega highway of the body. So with this, you kind of see how it branches off here, the little arrows. This is going to areas that are above the heart, like the brain, that really need oxygen, that really needs oxygenated blood and whatnot. So understand that your brain needs nutrients, your brain needs oxygen to survive. That's why it's really hard to hold your breath for a long period of time. Your brain is really sensitive to carbon dioxide. Your brain constantly needs an influx of oxygen. So the aorta is going to be delivering that primarily to your brain when it splits off at the top here. But then the aorta kind of curves downwards and it's going to go down to the rest of your body. Okay. To the rest of your body. Before we move on from this diagram, there's a couple other words that haven't been covered. You have these tissues called the endocardium. The endocardium, the word endo is meaning with inside. So the endocardium means it's tissue, heart tissue or heart muscle, heart tissue that is inside the heart. You have myocardium, which is the center tissue, the middle tissue of the heart muscle. Then you have a thing called the pericardium. The pericardium is like this lining that's around the heart. The heart is encased in with like a film almost, it looks like. But the pericardium is incredibly important. And when you're sick or have heart disease or fluid around your heart, it can collect in this pericardium. However, when the fluid gets too much, you have cardiac edema or pulmonary edema. When that collects around the heart, then you can have some heart failure issues. It's usually referenced to as heart failures, when you have fluid built up around the heart. But the heart is a really important organ, and it's incredibly important that you take care of it because you only have one, and you can get a transplant or a pacemaker, but pacemakers are usually reserved for people that have imbalances with their they may have a heart murmur. A heart murmur is a valve that's leaky, or your valves aren't responding the way they should. Or a lot of times if someone is born with a hole in their septum, they have to have that repaired with open heart surgery when they're very young, because obviously you don't want oxygenated blood and deoxygenated blood to be mixing here. But let's move on for a bit. So this is just a diagram of how the heart works. So blood with oxygen is going to be exiting the heart, going up to the brain. It's going to curl back around. And then this little diagram here is like demonstrating the body's tissues. So the yellowish tissues here are like the tissues that need the nutrients, that needs the oxygen. It starts off with the artery, and then the farther away usually is the smaller the vessel gets. Not all the time, but usually. So capillaries are the smallest vessels in your body. So capillaries, what they do is they're so thin, they're so small that carbon dioxide and oxygen can freely pass through them to the cells that need them, or the tissues that need oxygen or nutrients. Without the capillaries, the delivery for nutrients and oxygen would be much more difficult. So your body efficiently wants to be the most efficient at using oxygen. The more efficient your body's using oxygen, the less it's going to have to work and less that has to do its job. And counterintuitively, or at the same time, rather, the heart is a muscle that you can train with exercise. The stronger the heart that you have, the less beats that it will take to do its job. That's why you have to take care of it and make it stronger with cardiovascular exercise like biking or walking or running, rowing, swimming, something like that. It really depends on the individual too. Sometimes walking is just enough to raise someone's heart rate. So let's move on here. So the tissues have used and abused the oxygen molecules, the nutrients, but you have this byproduct and you still have the tissue, you still have the liquid of blood, flowing freely. It's almost like it's dropping off here, dropping off the supplies or the goods. But what's going to happen is the oxygen is dropped off here. You get carbon dioxide as a byproduct. It's going to flow through the venules. So if you really want to measure how efficient your body uses oxygen, you're going to measure the level of oxygen here and then also measure the level of oxygen here and see how much you have left over. There's never really 100% usage rate. So that's why when you give CPR to somebody, you're still going to have oxygen left over. You're still going to have oxygen to give the person with mouth-to-mouth breathing. So moving on here, the blood will then return from the veins from the inferior and superior vena cava and then enter in the right atrium here. Pretty simple once you think about it. I'm not going to talk too much more on this PowerPoint, but it's kind of getting lengthy. So one of the more important things too is to understand that your blood is primarily composed of plasma. And plasma is primarily composed of water and solutes like protein molecules, amino acids. But then also you have this smaller amount, but still really important, is these erythrocytes, otherwise known as red blood cells. Red blood cells are important at carrying nutrients and oxygen, iron, things like that. But then you have this middle layer that's very, very small, very, very small, called leukocytes and thrombocytes. So leukocytes are white blood cells and thrombocytes are like platelets or clotting material. So when you form a scab, that's platelets doing its job, clotting elements doing its job. If you put your blood in a centrifuge, it would look like this. At BioLife, you can donate your plasma and then have the important red blood cells be shot back into your bloodstream. Plasma is really important for patients as well that need it. One more thing about this is that at altitude, so if you were to move to Colorado at altitude, this ratio would be a little bit different. You would actually have less plasma and more red blood cells. Because at altitude there is less oxygen, so therefore your body actually compensates for the less oxygen by creating more red blood cells. However, that kind of takes weeks, 3 weeks or so at a time to create the necessary amount of red blood cells for it to compensate with the less air. So when you arrive at altitude, you may seem more tired. If you haven't been living there, you may seem more tired. You may have to go to the bathroom more because your body's actually getting rid of that water in that plasma to shift that ratio from more plasma to more red blood cells. Here's a little trick though. So a lot of times, like distance runners, before a big competition, they'll live months at a time. They'll live months at a time at altitude in Colorado. And there is actually an Olympic training facility. They'll live at months at a time at an altitude, and then they'll come down from altitude, maybe wait 3 days, and then compete. Because the benefits are, with the more red blood cells you have, the more oxygen that your body can carry, the more efficient it uses. And with distance running, it's all about using oxygen efficiently. Just kind of want to throw that out there for you. Last one we'll talk about is the lymphatic system. Lymphatic system is composed of lymph vessels, lymph nodes, spleen, and the thymus glands. So if you take a look at here, you have lymph nodes underneath your armpits, you have lymph nodes in your neck, you have lymph nodes in the inside of your thighs, you actually have lymph nodes by your stomach, and also your spleen is a part of the lymphatic system. The spleen's job is to destroy old blood cells so that the bones or the bone marrow can actually create more white and red blood cells. You want to destroy the blood cells that aren't working very well. So here are some of the immune system functions. It's to protect the body against pathogens such as bacteria, fungus, and viruses. Those are usually the big three when it comes to microbiology. Foreign agents that cause allergic reactions, such as insect bites, and also abnormal body cells, which are cells that are old or mistakes that your DNA has created or failed to, or your DNA has created. But the problem is when you have a mistake cell, those mistake cells can multiply and create a tumor, and that's what creates cancer. So cancer is just referenced to as, cells that are supposed to die off and be replaced, but aren't. And those mistakes get copied over and over and over. So you have 3 lines of defense, and this is the last slide I'll talk about here is, you have the pathogens on the left. You have allergens, cancer cells, bacteria, virus, and insect bites, carrying things like malaria. So your first line of defense, and this wouldn't apply to really cancer, really. Your first line of defense would be saliva, earwax, and mechanical barriers. So mechanical barriers are things like skin and hair, nose hair, earwax, ear hairs. Those are your first line of defense for trapping foreign agents. But then you have the largest and most important cells or line of defense in the body, and that is white blood cells. White blood cells contain things like, one moment. Sorry about that. So as I was saying, natural killer cells, these cells right here they're like the foremans or the job site managers of the leukocytes or the white blood cells. They will actually hunt down cells that aren't doing its job and destroy them. Or if they see a cell that's not functioning the way it should be, they'll destroy them. Or if they see a pathogen or a bacteria that shouldn't be there, they'll destroy them. But they're literally labeled natural killer cells. They will naturally kill cells that aren't doing or should not be there. They're like the attack dogs. But then you get these little things called phagocytes too. Phagio means eating, but they literally mean eating cells. If you can look at them underneath a microscope, and you can see them engulf bacteria, and it's actually quite interesting. Then you'll have this thing called inflammation and fever. So this is whenever you get a fever, your body naturally will increase the temperature. By increasing the temperature, what will happen is your body is fighting off a bacterial infection or a virus or something like that. But a lot of times, bacteria really does not like to live in an environment that is hotter than 100 degrees. So your body, by raising the temperature, your body will destroy the infection or the inflammation. The inflammation means that it wants more blood to get to that area. Last one is protective proteins. Protective proteins are things like amino acids or BCAAs that protect your muscle tissues or protect your tissues in general for injury. And then last but not least, you have the third line of defense. The T cells and the B cells, without these two, it's like the mommy and daddy white blood cells. Without these two, you're not going to have any of this. So that's why there is one particular disease called HIV that will bypass or skip past or get into the body past all of these lines of defense and will go straight to the T and B cells and cause your immune system to be what they say compromised, and your body really can't do anything without T cells and B cells. So antibodies are the most important things, and without them, you're not going to have these. So I just wanted to end off with that. The video kind of got a little long. Make sure that you're looking at your book and you're getting all the combining form words and definitions. Thank you.